All right, back in business. Everybody here? Yeah. Okay. All right. So now this afternoon, I was thinking we will move over and have a look at Navigator, set up experiments in there, and we will use most of the things that we've covered in the morning. So I will use the same sample for this. So I have my 3 probes here. I set it up using these quick selections. And right now I have the 5x objective, so an overview objective. So if I was to image this and I wanted to do some tile scans or multi-positions and so on, so use Navigator, this is what I would do. After starting this up, I would set up my channels because I know the fluorophores I have. And I would make sure that this is correct, as we discussed just before. And then I would go to the 5x objective. I would take the one color that would make most sense, that would allow me to see the most interesting part of my sample. In this case, I would probably select the green stain. With the 5x, what I can do here, I do it sometimes out here before going into Navigator, just because I'm more familiar with this one, but you can do the same thing in there. We'll go live, turn on the light, and just have a quick look to see if is this enough. And I think I would probably increase this a little bit, and I would probably increase the exposure time. But this is not I'm not trying to get the sort of necessarily the best image here, but I want to be able to identify something about my sample. So now these settings, I think they will be quite okay for what I need to do for my overview. So now I will start Navigator. So Navigator we find here. So I will just click on this. This will open up a new interface. We're still in the same software, nothing has changed, just the interface changing. So we can still see that, so the interface looks different, as you can see. Over here, top 1, projects, this is our file tree. We recognize it from before, so that follows just as before. So whatever we do in here will follow back to the other and vice versa, yeah? Beam path is this window that we recognize. It looks the same, it's the same settings that has followed over. Image, it's the same thing here. We have the exposure, so the camera settings, the different dimensions. You can see that these 2 buttons are missing because we are already in Navigator. So projects, this is this one. So the 2 new ones are stage. So here we have the stage settings that we might want to consider. So we have the tile overlap. So if you do a tile scan, you want images to overlap a little bit so that you can stitch them together. This overlap, default standard is 10% overlap. This, however, you might need to change sometimes depending on your sample. Sometimes you might need a bigger overlap, sometimes you might need a smaller overlap. So it depends on your sample. But 10% will most likely work for most of your or maybe all of your application. And then you have a few different options. They sort of describe themselves what they are. If you want, you can click on this to go and read more about them. I will not talk about them individually now, but the last one, merge images during acquisition. So if you want that, you can activate that. So I will activate it. You get a few more options. Get the option if you want to keep raw data. That's always on per default. We recommend also, if there's not special reasons for deleting it, I would suggest to keep it. But you can also delete it. You can merge data in 3D. So if you do a set stack, you can merge if you do a tile scan with set stack, you can merge them normally. Then it would try to match each first Z level with Z level and so on.
Mhm.
But if you activate 3D, it will also look in the Z stack if you have how this matches better over here or here. So this you can also activate to get a better stitch, but it will also take a bit longer. And depending on your sample, it might be something that will give you a better result, or sometimes it won't matter at all. So it's something you can test. If you keep your raw data, you can always re-stitch your data with different settings. If you realize, okay, this setting didn't really work so well, so maybe I re-stitch it with the 3D activated and see if I get a better result. You also have a blend. In the blend, you have 3 options. I think smooth would be where you would be. Most people, that's the standard. For some specific samples, statistical could give you a better result. In some case, maybe none would be something you want to do, but I would say smooth is where
What exactly is that?
So, in statistical, so what you can get sometimes with smooth is that in the overlap, when they stitch, it can be a bit smudged if the samples are, well, for some sample that might happen. In those cases, statistical could give you a better result. The algorithm behind it, I'm not really sure.
Okay.
And none, I think, then they will match it, but there won't be any sort of transition going on.
So it's basically on how it gets like stitched together.
Exactly,
and
yes.
how the overlap is going to be handled.
Exactly.
Okay.
How the overlap region will be handled.
Okay.
So smooth is most likely where you will be. That's the one for all the. So I work mainly in life science, so smooth is where we are always. So okay. The other one is carrier, and the carrier is where we can load sort of an avatar. So this is now the viewer. So if I scroll out here, I use the scroll wheel. I'm going out, and here we see another rectangle. This rectangle is the total travel space of the stage. So this defines the travel range of the stage, meaning that in theory we could have sampled anywhere within this travel range. Yeah. This here is our current field of view. So this is where we are, the position, and with the 5x, this is the size of the field of view. If I move this to the 20x, that's the field of view. The 40x, that's the field of view. The 63x, that's the field of view. So to see the whole thing, you can scroll or you can scroll in. You can move around by clicking and dragging, and that will make more sense once we have something here. So if we go live here, we don't see anything, but we can do this auto scaling. Here it's called auto range, and there we have our sample. So now, if I want to know a little bit more about my sample, I can start what is called a spiral scan. So the spiral scan will, with the current objective and the channel, it will go just around my sample and take images. Just put them next to each other. There is no stitching. There is nothing happening here other than this.
Yeah.
Whenever I feel like I have enough information, I can stop this. This will just continue until I stop it. And now I can move around in this one, and I can try to find my points of interest, let's say. You can also see that the borders are not perfect. You can clearly see them, but that's not the idea with this overview. This is just to navigate around here. So once I found something that, okay, so over here, this is what I want to look at, for example, I can double click here. The stitch would move there. It would also take a picture. Just overlay that. Change that a little bit brighter. So now I'm in this position. You can see always where I am with this. I can also, if I scroll out to see more, I can always quickly go to my field of view by clicking on this one, move to stage position. That will sort of maximize this one in the window. Okay, so this is interesting, but I get limited information here. It's a 5x objective. It's not very detailed. So I will now change to the 20x instead. With the 20x, I might get a bit more information. So I can go live now, and I will see. I will also do this. So now I'll see much more. So we can see that this one is now overlapping with this position where we were. I remember I have quite long exposure time, longer than I need, so I will reduce that. I still have the outer range, so it adjusts automatically. I'll also drag this down a little bit. I don't think I need, especially for the demo, I don't need the full. We can still see that I have, this is the histogram that we're looking at here. You can still see that the maximum is around 2,000 counts, so I think that's pretty good. So I think that these settings will work well for this objective. So now I can say, okay, is this an interesting, I can see if I can adjust the focus a little bit. It looks pretty good, so there. If this is something that is interesting, I can mark this for later acquisition. So I can click on mark. Creates a little arrow there. I can look for other places, maybe this over here. So I double click here, we'll move to that position, zoom in. You can see I'm not in focus anymore. I've moved over the slide, which might not be perfectly flat and all that. So I have to adjust the focus a little bit. And if this is something I want to capture, I can go with another mark. Now I have these two marked, and I can move between them. I can click on this, it will move to this position, and click on the other one, it will move to that position. One thing here, so this is the mark. So this is for me, one of the better ways if you're gonna do multi-position. So a single frame, but several of them, yeah? Mm-hmm. Is this something you will do in your research, do you think? Multi-position with single frame? Yeah, I figured that might. Yeah. So the mark position, that saves the X and Y, but also the Z. So that saves the Z position, which is then good. Because there is also what you can do. You can also click on this one, single plane. So all of these tools here is different region of interest tools. So I can also click on single image, and I can add a single image. Like, okay, I want to capture this. So I see here that now we have one more image there. I might want to take this. But these positions, they don't have a Z position attached to them. So if I go live now, I might adjust the Z a little bit. But this Z value is not saved with this position. So if I want to, if I use this one to put a bunch of single images, I would have to use something else to adjust for the focus differences in my sample. So if I have a fixed sample like this, and I want to do multi-position, I will use the mark tool, because it also saves the set. Yeah? So now that I put something, so something to notice here. Whenever I put something, a marker, basically when I put a region of interest, I'm getting more things happening in my task list over here. So in the task list, they keep filling up with things that it will do, things that it will image. The first two were the ones that I had used the mark. We can see it has a little thing there, and we can see that it's a Z attached to it, whereas these ones don't have this Z attached to it. This will also go if I instead of doing single image, if I draw a rectangle here, I will have my rectangle. It says 18 tiles. We can see, if we zoom in here, we can see how the tiles look. You can also see the overlap here. Okay? And I can continue to draw more regions of interest. Yeah? There are other tools. You have the polygon. The polygon allows me to draw something that is not necessarily square or rectangle or something like that. And I double click to finish it. So then it will add the field of view. It needs to capture exactly what I drew here. This can be an advantage especially if you're doing maybe tissues or anything like that. That is not a square or a perfect circle. Because although an image, a stitch image, always have to be rectangular. It's a file format, so you have to have a rectangular image. So if you stitch this together, it will go faster to acquire because it will only acquire the areas that you're really interested in, and all the rest of it, it will cover with black frames. So the acquisition will go much faster, and also the file will be smaller, but it will have to do in a rectangle image, but it fills out everything else with black. Yeah. So that's the polygon. You also have ellipse, and how to draw this. You click once. You click once and you drag, you hold, and then you release. This is very okay. Let me just check this because yeah. So stupid. The circle, you click and hold and drag. I think this might be a bug. And then you release. Whereas the other ones, you click once and then you drag it and then you click again when you want to release it. I'm not really sure. I think that's something wrong in the program, actually. I was surprised. Either way, so in this task list, if you've drawn something that you don't want, you can always remove it here. Just delete this region. You can also, with the select tool, select one. You can move it around. You can also angle it if you want. You can also resize it.
Yep.
And you can also delete it if you have that selected. Okay? When you have done a polygon, you have all these little squares, little things, so you can pull those out and you can resize the polygon also if you want. Okay. So that's the region of interest tools. Yes?
Just one more thing, whenever we do anything in the region of interest tools but mark, the Z position is not saved or anything, right?
No, exactly.
Okay.
It's only with the mark position. Yeah. So if you're gonna do this experiment with these two field of view that I did the mark, then if you did the mark, this would be fine to go. I have my three channels. I have my two positions. You can check here that I have the channels. You can also see the channels up here. So you can see which ones you have. You can see the settings of the different. Now we're live, so we can also see it here. You can adjust these so that everything looks okay. You can check the exposure time just as before. And once we are done here, I can go start. The start button is over here. So starting this, then it will go and run everything in the task list. So it was these two. So now we can see it captured this, and it captured this.
And every time when I choose a field of view, I have to readjust the focus?
That depends that depends on your sample and how flat your sample is. Yeah. Most of the time, especially if you're moving over larger areas, typically you would have to adjust it. If you have something like a cover slip like this that is mounted on a glass slide, very often you grow your cells on the cover slip and then you mount it on the glass slide, but with some mounting medium and so on, and then you're resting it on the glass slide. But sometimes the mounting medium might not be perfectly flat neither, so your cover slip might be slightly tilted. And if that is, then if you move over it, you will have to adjust it. So doing single frames like this, mark, then you save the Z, so it's easy. But how do you do if you want to say that we want to do a tile scan over this? And how about, let's see if we have Let's go over here. Double click over here. We move it there. We go to green. Go live. Check the focus. Focus looks good. We go over here. Check the focus. Focus is not good. So if I run this one now, let's do this actually. Just for simplicity, I will just resize so we just have one. So if I run this, now we'll do all these three, and we already know that it will not be in focus here, but it should be in focus over here. Sign that my cover slip or the slide is it might be tilted. But here, okay, it's not perfectly focused, but it looks pretty okay. And then over here, it's not in focus.
Yeah.
So the way to adjust for this, if you have a sample like this, then I can then use what is called a focus map. So I can put focus points here. So we have the next focus map point. It's the blue little cross here. Hover, focus map point. I pick that. And I will put 1 point here. And we'll put 1 point here. So what the focus map is it activates this tool. I open up, go to the first point. I will zoom in here a little bit better. Go live. And I will find the focus. Somewhere there. And I set. And now I move to the next point, which is then on the other side. And I will adjust the set. Over there. And I say set. So we can see here now that these are in two different set levels. So what will happen now when I run this this experiment is that it will adjust the set as it moves through this. It will interpolate between these 2 points. So as long as my sample is flat, then everything should be in focus. In some cases my sample might not be flat, but this is the way to then get the focus over this whole range. So that would be the same if you have a larger tile scan. You might need to...
I know that the main profile of this one is not the microscopic scanning, but isn't there an option for that, just to give it that, make the automatic focus points?
Yes, we're coming into that too also. So if you have something like this, you can also set up a focus map, but then you might need 3 points, for example, or sometimes even more points. But the idea with the focus map is mainly to correct for tilts, meaning that your sample is flat, but it's tilted. So then, in theory, you would need 3 points to correct for a plane. But very often, there is more to that than just a tilt. There might be, if there's a tissue, then the tissue might be a little bit like this. Even if you have cells, there might be some irregularities on the cover slip or so. So you might need a bit more. But yeah, the focus map points is something to use in the beginning. You also have the possibility, if you set up several of these, if I open up this tool again, where we have our points here, I'm just gonna clear all the set, like we haven't done anything. I can go to the first one, and I typically would just check so that I am more or less in focus on that one. And perhaps set that one by hand. But then you can find the remaining by autofocus. So doing that, then it would be going around and setting the rest using autofocus. However, I think, let me see. Yeah. So it goes through and trying to find it, but this was the first time I did. Here you have the settings for the autofocus. The settings for autofocus, you have fast, if you have this one over here. On the other side is precise. What this one is actually saying is that how many steps it's gonna do over the range of 80 microns. Now it was set all the way to here, so it basically did 2. so that will not work for especially a sample like this that is so thin. Also 80 microns is probably more than I would need. But I would play around with this to get a better fit. So let me go back to the first one. Just make sure that I'm in focus, and then I'll just clear this. We'll see if it works better. So it said remaining. So now it will do. You see now it takes longer time because it's doing many more set stacks, set positions through this stack. You can also see that it's actually moving much more than it needs to. But that's something you can play around with the autofocus. So there you can also see that it found a good focus for this. So you can generate the focus map automatically if you have a nice sample for that and so on by using find autofocus. Saves you a little bit of manual labor if you have a lot of focus points.
But the focus map, it's working only in a range, right? So if I choose only 2 field of views, then...
No, so now when I put the focus map with these 3 points, anything else, even I think like for this whole travel range, it will interpolate. So even if I take an image out here, then it will use these numbers to calculate what is the focus out here. So it will do a job for that.
But
So I would say
continuous, so if there is a tendency of getting out from the focus towards the upper point, that if you use that tendency or just choose the same polygon or same, I don't know, same map again.
I'm not sure I follow, but what I would say is that it would use the plane that it will calculate, the focus plane it will calculate with these 3. That plane would continue outside. However, like if I put focus point, I would typically make sure that everything that I image is within my focus map. So if I wanted to image something out here, I would probably put either one more or move this one outside, so that I have more focus points from my focus map. So if I wanted to take some images out here, I would probably make the focus map even include these ones. I would probably maybe add one more here, maybe one more here, and so on. So you can do more. So if you do more, it might not be geometrically a plane in the background, but I mean, for you it doesn't matter. You will just use your numbers, and anything in between it will be interpolated. Okay, so that's the focus map. I will remove all of these. And I will remove these ones. The other thing you can do is, as you say, you can also use this autofocus to actually look for the focus in this. So if I want to take this one now, I already know that everything will not be in focus, so I could either use the focus map, but now we'll see how can I use the autofocus instead. So I will go into here, and as you remember, when I activate autofocus I can't be live, so I will stop the live. That will allow me to press the autofocus panel. Comes up here, and it looks the same as before. So here we have my settings. We can't change everything here. Most of it is or a lot of it is fixed. But what we can change is the capture range. So right now it's for 100 microns. I know that my thickness of my actual cells is about 10 microns. So this would be probably quite excessive, but you will also have to consider how tilted your sample might be. Because if you move far and it's very tilted, and it just goes in this range, it might not cover what you need to. So it's something that you would have to learn with your sample. But I will now put this one for 25. We have the precision again, speed or accuracy. Here we can even see the number of frames it will do. So if I say 9, if I do a little bit more towards accuracy, it will do 9 steps and so on. You can also select and actually say how many steps you want it to do in this range. So that's one thing, that's setting up the actual process of where it's looking for it. And the other thing, now this is a stage experiment, so I can go into the stage setting, and here we have the next one. Should I look for the focus just in the first position? Or should I do it every position? Or every third position, for example? So that's up to you to decide how often you need to do it. If I'm not making a tile scan like this, I will probably not do it in every position. It will take time, and it will also most likely be unnecessary, because from there to there will probably not change so much. So I might play around with this one and set it for every third or every fourth, or so, depending on your sample. You can see, let me see if I can illustrate this. It's a bad color. I don't know if you can see the difference in this color from this color. This is green. The background here is unfortunate because it's green. Let me see if I can change. I don't know if you can see it better. It's very, very thin, this line now. But this is green and this is white. And then this is green again. So that's basically showing you which positions it will do a autofocus job. So right now it will do it in the first one, 2, 3, it will do it in the fourth one, 5, 6, and then it will continue. So you will do it there, there, and so on and so forth. Yeah? So that's one way that you can set up this. So now we will do an autofocus job every third frame to keep it in focus. When you do that, there are a few things that you should need to consider when you use autofocus. This autofocus is contrast based or image based. You're looking in the image, looking for contrast. So running this thing, every third one, this will completely throw it off. If it's doing an autofocus job here, this runs the risk of really putting the focus completely wrong.
Yeah.
So this is why I'm saying with the autofocus, software autofocus, you always have to have a little bit more consideration when you set up where you do that. So this automatic might not always be best. So then there's another way to choose where to do it. We could do it in the first only, every, or every second, third or so. But we can also use this tool. This is right next to the focus map tool. It's the green autofocus point. If I activate that, I can actually tell where I wanted to do an autofocus job. So now I can pick places where I see that here it looks good, here I can do it. Might want to go close, but not exactly, so there I can do it. And there. So this is one way. Now I've actually selected exactly where to do it. So now you can see that this is green, but this one is not green. And this one is green, and so on and so forth. If I go into the autofocus, now I can see here are all the points listed where it's going to do all the X and Y, where it's going to do a autofocus job. You follow so far?
Yeah.
So with the autofocus job, the last thing to consider here is that the autofocus will always be done in the first channel. So you have these 3 channels here. You can open up this. WP, GP, RP. So you need also to decide which channel is best for my autofocus. And most of the time that's not going to be WP. Very often. So if you want to do it in the GFP, you should make sure that the GFP will be the first channel. And for capturing these kind of things, it doesn't really matter which channel is first. The times when you might want to consider that is if you have a very sensitive sample, that bleaches very easily. If you have a sample that bleaches very easily, and you need to have long exposure times and so on, you should definitely start with the most red fluorophore. So if I had something like that, I would start with the red and then work my way down in the wavelength scale. So we'll start with red, green, and then yellow. This is to preserve the sample as much as possible. But yes, so with the autofocus job, it's always going to do it on the first channel in the row, so make sure you pick the correct channel for that. Okay? Any questions?
Can we in theory also do the autofocus and bright field?
Yes. To have a bright field channel is...
Yeah, and then just as usual.
Yeah, exactly. So you would just have the bright field channel, and if bright field is the first one, then it's going to do an autofocus job on the bright field. Yeah.
Does it make sense to make the autofocus and bright field? Does it?
In most cases, I would say no would be my first impression or suggestion, but it depends on your sample.
Okay.
In bright field, what gives most contrast and so on, which is what it's looking for, might not be in the same level as your fluorophore.
Yeah.
But you haven't got the contrast stain usually together with the fluoro stain. So the bright field, you can make a sharp adjustment with the phase contrast, but the phase contrast it's more like focusing on the edges and not on the inner content.
Yeah, yeah, exactly. So between bright field and the other type of transmitted light contrast methods, the focus is very often not in the same position because you're not looking at exactly the same things. So I would suggest to pick the whatever channel that is perhaps having the most important. If it's very light sensitive, that's also something to consider because then you might not want to do a autofocus because that's expose your sample with light. So in those cases, I might go for that. But I would say that if I had a sample like this and I have sensitive material, I would probably use a focus map instead to take charge of that and find the focus like that. Because to find the focus, let me go to this position. I'll go live here. Let me go to this. So right now it's quite easy to find the focus. Let's see if I can force this up. So right now we have very little light. I'm down with 5%. I can probably go even more. So even here, with very little light, I can probably still get the correct focus. So if I have something that is very sensitive, I can, if I do it manually, I can find the focus. Also, the computer would be able to find this focus much easier. So that would mean that if I had... So on this system is like a one function that you can have on DMI8 like this. That's a function that makes the whole system go even faster. It was something that was not really crucial at this point. It might be something you upgrade with in the future. It's a very simple upgrade. And it's called Synapse. And if you have Synapse, the autofocus is actually getting more functions. In that case, the autofocus would be a separate channel that you have full control over. So you could actually set that up so that if you set up the autofocus channel, you can set that up with very little light, very short exposure, so it goes fast and so on. But it's still enough for the algorithm to actually find the correct focus. So that gives you even more. I think that if you're working a lot with this and if it's something important, such an upgrade could be very helpful for even that. And that's not a very difficult upgrade. But in this case, since we are locked to always doing the autofocus while running an experiment on the first channel, then with the sensitive sample, I would probably go in and do it by hand with an autofocus map, where I can really go down and save my sample and just find it. If you have a sample where you also know what where what your bright field looks like. I had a user I was working with last week, and she wanted to use the bright field to set the focus, but she wanted to capture fluorescence. But she also knew how her cells looked when the fluorescence was in focus. So she could focus it so it didn't look, in my eyes, wasn't the sharpest, most focused position. But that's when she knew that then my fluorescence is focused and it worked. So you can absolutely do that. So, but then it will only work when you do it manually, because the computer would find a different position. Okay, so that is a lot about focus and autofocus stuff. Sounds good. When doing all of this, we can of course remove this. I will set this back to green. As you can see, whenever we do something like double-clicking somewhere, it will add another image. If we do a spiral scan, or if we take an image or tile scan, it will add images to this list here. Anything that is preview is just stuff that we have under this preview. There are several different previews, but all of those are stuff that we've done as a spiral scan or just double-clicking somewhere and so on. So none of those images will be saved when we close this session of NSX. But we also have stuff that is called series. And series, that's what we captured. Those also show up here, so we can remove them. Let's see if we can find a series that. I was wondering where this series was. Okay, can't remove it. So we can view or remove, like just visually take something away to see less, but we can also actually remove previews that we've done. So let me see if I can find. So this preview, for example, is this one. So if I want to remove, I can just take it away. It's gone. It's not saved anywhere. I can also remove a series. So this series here, I can remove that one. But if I remove a series, it just removes it from this overview. It doesn't delete that data. It's just this is just displaying what I have here. Preview, it's not saved. If you take it away, it's gone. If you want to, for some reason, save this overview, you can, but you have to click here. And then you give it a name, and it saves whatever you're looking at here. But if you want to save data, it's better to actually take an image and save it like that. You also have the possibility to go in to each preview here. Let me see if I can get. This is the big preview that we did. I can click on this little guy, and I can go in here and adjust the contrast of that specific preview with both color and contrast to see it better. So that's something that you have the option of doing. All of that is just to help you to see where you are and navigate and so on around. But that possibility is there. Alright. So we're almost. What else? Oh yeah. Let me remove the autofocus. I will not work with autofocus at the moment, so I will take that away. All these experiment with mount position and tile scans and so on, you can of course combine it with the Z or time. Clicking on Z, I activate it, and again I'm getting the tool only when I need it, and here it is. It looks very similar. It's almost identical to what we saw before. It's slightly different, but more or less identical. So again, you have the beginning and end. You would set it up the same way. I can zoom in to the stage position. I can go live. I don't see anything, but I can rescale it to see if I can see something. See here. I'm not in focus at all. Oh yeah, I still have this one. Let's go there. So just as before, I can go to the top, go begin, bottom, say end. I have my stack. I have the beginning, the end, where I am right now, the set size. I can drag this into the middle if I want, and I can go through my set stack. System optimized, number of sets, step size, so on. So it's all there. One additional thing that you have is here, same set stack for all regions. So when you do different regions in Navigator, all the regions, all the images have to have the same settings when it comes to the number of channels, the exposure time and all that. They are all identical. Except for one thing that you can change per region, and that's the set stack. You can't have different sizes of the set stack in different parts of the image if you want. So this one, if it's like this, then it will be the same in all regions. So I will just pick a few. So that will do the same set stack. But if I untick this little button came up, redefine stack. See, the button disappears, but if it's there. So this means that I can go in and I can say, okay, I want to redefine the stack to this one. So right now this is exactly the stack. You've got this little cube, means that that one has a unique stack. I can go to the next one, and here let's change this. I can set this to say, 5, make it a little bit fast, and I redefine the stack like that. Then it has a different stack. So now depending on the position, it will have a different set stack. This one has the 10 microns almost, the other one has the 5 microns. So the set stack size is the only thing that can differ between different regions. Otherwise, everything else will be identical. Alright? But my main point here was that you can add Z dimension to these experiments very, very easily.
But if I use a focus map, for example, then the Z stack will be automatically changed between the...
Yes.
Okay.
So the focus map will always point to the point in focus, which will always be the middle of the stack.
Okay.
And then it will be adjusted.
Yeah.
Okay.
So as the focus map is interpolated between these positions, the Z stack will also go like this. And if you're using autofocus, it's the same thing there. Like if you're doing an autofocus job here, finds the focus there. The Z stack will be symmetrical around it. Goes to the next place, do a focus job, finds the focus there, it will be symmetrical around there. Okay, so remove that, and sorry, I will take that away, and time the same thing there. If you want to run a time series, you can do that too. And the tools are the same. Consider that if you do a lot of different position or a big tile scan, that will take time. So you might not get a super high frame rate, but normally that's maybe what you want to do if you do a time over many positions. All right. So let me remove this. Yes. And I will also remove all of these. So all of this you can remove one by one if you did something you felt like, okay, let's put this away, or you can take away all of them. I wanted to show you this carrier function. So in the carrier function, we have a bunch of different avatars.
Oh, just a question about the system. Does it have the, when it combines the different levels, it's called more optical combining of sections? So can you just apply that you have, I don't know, pictures about 5 focus sheets in this Z stack, and can you just combine them to have the, discard the out of focus and
so
now the...
Yeah, so I think you're talking about the maximum intensity projection.
I don't know.
So if you do a Z stack, you get 3D information, but then you can collapse that down to one image that takes for each pixel takes the highest intensity in that pixels. So this you can do. It's done in a different part of the software, so we can have a look at that also. So the carrier. So this is something that I think if you're working with 96 well plates or any well plates, this is very useful. With slides, maybe not so useful, but you can use it. So this is avatar. So if I click on the carrier, this is now you can select what type of carrier you have. Carrier is, I mean, in this case, this is a slide. That will be my carrier for my sample. So if I have a slide, I can click here, slide, and there's a bunch of different types of slides here. So what I have here is could be a glass slide standard, 75 times 25. So if I click on this, I'm getting this avatar. So this one then could help me in some way to orient myself where I have my sample. Per default, it will always just place this in the middle, but perhaps especially with this frame that I have, I mean, I could physically move my slide to over here or over here. So I would have to align it, and there is an alignment procedure that you can use. I will not do that with the slide because, again, the slide is maybe less important. Something where you can use it is if you have a 4-slide holder. If you have a 4-slide holder and you're doing a lot of scanning of multiple slides at the same time, you want to set up an experiment where you do the same experiments again. Even if you do several slides, it will have to be the same channels and exposure and all that on different slides. So then you could scan multiple slides at the same time. Just set up your experiment, you press start, and you go for coffee. So then it can be good. But where it's really, I think for you, it would be mainly to use these different kind of well plates. So I will show you the well plate. There are a few of them in here. If your brand is not in here, you can add your own. So we'll also have a look at what that looks like. But I will show you what this is. I will find the 96. I will take this one. Clicking on that, I'm getting my 96 well plate here. And now, what I can do is I can pick which wells I want to image. Here, I can do multiple by holding the control. So this way I can pick which wells I want to image. You can easily do the whole one if you want. Once you have selected which wells you want to image, you can also choose how do you want to image. How do you want to image in each well here? So I go well coverage, and here I can then choose if I want to do a mosaic. Mosaic is a tile scan. So this would be saying either I want to do 3x3 tile scan in each well. It will do that in the center. Or I can say I want to image so that I have say 50% of each well I want to have image. And if I go OK, it will then add a region of interest that covers 50% of my well. And in that, it will automatically also add the number of frames it will need to cover that 50%. So if I instead say, like, for me it's okay with the 3x3, I can do by 3x3, and I will do that in each well. Okay? The other thing that I can do is I can, instead of doing tile scan, can also do positions, which might be more interesting if you have just grown cells there. You might want to do a few position in each. So let's say that we want to do, say, 5 position in each well. I want them to be random. I can choose if my field of view can overlap or not. Most of the time you don't want them to overlap. And also if I want to have the same pattern in each well, or if I want each well to have a unique or different pattern. It's up to me to choose. I can also set the bias if I want these to be a little bit more biased towards the center, which might not be bad idea with well plates. Sometimes when you get towards the edges you have edge effects, so you might want to put it a little bit more towards the center, or in some cases you want to put it a little bit, or image a little bit more biased towards the edge. And we can say OK. So now it puts 5 randomly distributed field of views in all of these. You can absolutely go in and you can select one and you can move that around if you want. There is a reason for it. And you can also see here that you have the task list now is helping you to identify. So row A, well 1, is these ones. So when you capture this, the naming will also be according to the well. So all the images that is taken in well A1 will have that that name also. So you will be able to find where they are from. New in this release is also that you can set focus points. So if I set focus points here, it will then add as many focus points per well, or like in this case I selected this whole thing, but if I didn't have all of them. Now I took 3, maybe 1 is enough, maybe 2 you want, or something, but it adds that automatically. You can also, of course, not use the set focus point there, and instead you can just use this tool here. Oh wait, first row, I have to remove all the ones that was set automatically. And you can also just set, I mean, if this is a perfectly flat dish, this could be enough. Most likely you would need a few more. But yeah. Okay. Do you follow this part?
But here, then I have to set the focus before, right? Or
The focus
here
map,
at
yeah, focus map is setting it before.
Okay, but at the navigator, not in the previous. So here I can set everything here at
Yeah.
the navigator,
Yeah,
right?
yeah.
So I don't have to use the.
The default interface.
Yes.
No, you can set everything here. So
Okay.
when you are in here, we can just go to. I will click on this to move, because right now I don't know where my state's position here is. So I can move quickly to that by clicking here. Ah, there I am. So if I go live here, I will see my sample, and I can easily adjust in here the exposure time of the camera if I want to. Let me see here. I have remove that one. So I can adjust the exposure time. I can also adjust the intensity of the light. So I can set things up also here. Absolutely. Also here you have the rescaling if you want. So I can make sure that all the things that I said before, adjust exposure time, adjust the light intensity, and adjust the scaling in a way that so you get something that is reasonable to what you want to capture. So that's absolutely possible to do here, and it has been getting better since Navigator was first released. So now I'm starting to do more here, but previously I used to go, when I tweaked my settings for each channel, I used to go back in the default, which is absolutely possible because everything travels. So you see everything that I've done now. You have all of this. I can click on this one to see my full thing. If I close the Navigator using this, I can go in here and say, okay, 170. So now I can tweak all my channels in here, where maybe I feel like more comfortable, which I do. And whatever I change in here, once everything is set up, once I tweaked all of these settings, I can then just go back into Navigator and start my experiment. Okay. So you can move between these two interfaces perfectly fine. Okay, so that's the carriers that are in here. The other thing that you will need to do, and we will have a look at this one once we look at your sample, because that's a 96 volt plate, is that you will most likely have to align this plate. And the alignment procedure is fairly simple. Just in case it starts moving now. So you would press the align button, and it tells you to go to well A1. It asks me to find the edge of A1. So I will find that, and once I've found that, I will press next, and it will tell me to find either the bottom or the top, and so on. So then I just move around to find those positions on A1. Once that is found, the rest is aligned.
Okay.
So the rest works. You have some options here. You can align for chamber edges or chamber center. So sometimes, depending on the field of view and the size of the chamber, sometimes the center might make more sense also. So you have those options here.
So I guess when we use one of the already saved plates which are there, like everything is set, the space in between the wells and everything.
Yeah.
What if we have to add one?
Yes, that's what we're gonna do right now.
Okay.
So, I mean, it is important that you have the correct measures, otherwise this will not work at all. Because some 96 volt plate, it might be in the, this is perfect, and the last one might be over here, so it's really important, that part. So, if you have another one, you go into here, edit custom carriers. So I click on this, and in here now you can choose what type of carrier type. So you can add a slide or anything, but we go into well plate. In here you would say my chamber shape is round. Number of chambers, 12 by 8. Let's go with that. The carrier size, horizontal, vertical, chamber size, chamber distance, and offset. All of these data is typically available from the manufacturer of your plate. So you find that on websites or something like that. So then you just plug that in here, and that then is fine. And once you have that, you just go save as. You call it something that makes sense, the plate and the number of wells typically, and that's it. And then that would be available. So then that will be available over here. So I'm gonna close this now. Go to well plates. You have the temp here, so I can pick that one. And of course, once you don't want it anymore, you can remove it just like that. All right, and you also, of course, 24. Let me remove all of these. Yeah. So that's fairly straightforward. Again, also here you have the little eye that will walk through all of these things if you if there is something that you forgot or so. But yes, for well plates, I find this quite useful, especially for setting up. So you get a little bit of semi-automatic workflow to quickly set things up. And of course, if you are working with a 96 volt plate, oh no, it's a different one. And you have done something that you so now I'm on the 5x objective, and in this 96 volt plate, then I can fit 5 of them. So let me do that again with the 40x. So you can also see that this is also, of course, following. So if I change now to the 20x, this will be bigger, but at that point they may also overlap. So once you set the number, it's good that you are on the objective that you want to capture, actually. So if you have done this, and you know that, okay, I'm gonna want to do this experiment more times, and perhaps you've added also a few of these focus points in here, you can right click in here, and you have a few things here. Save experiment. So I can save this experiment. So this will save a navigator experiment settings file, and that will then have everything that is in this. It has the well plate, has the channels and all the settings. So then you can quickly load that again. Likely, when you've loaded it, redo the focus map with the new plate that is in there, and then you're good to go. So this is a way to quickly go from arriving here, putting your plate, loading this up, finding focus with the focus map, for example. If you're using autofocus instead, at least find the first focus so that you're not like super far away, and then run. You can also, if I again right click here, you do have there's a few different, you can see that you have a few different options here. Ah yeah, it was here I think. Yes. So right clicking here, you get this save experiment, so that's saving the whole experiment. Some cases you might have something where you just want to save the regions. I'm going to use the same sample carrier, but my experiment might be very different. You can also right click here and then save and load regions. So you can save these regions, so that will just save the regions, not the experiment, the full experiment. You can save that together with the focus map, if that's something that you do. So you have those options also. And a bunch of other options, you will see it if you right click, and if you want to explore what they do, I mean, most of the time they are quite well described. So. Yes?
And it always gives us the time, how long it's gonna take, right? Is it
Yes.
fairly accurate, or?
Depends.
Okay.
It's not always. I think that the bigger the experiment, I have a feeling the more wrong it might be.
Okay.
So I'm not really sure. I never tested it. It would be interesting to hear if you're gonna test it and just have a look at that. That would be interesting to hear how accurate it is for you. Okay, I will remove all of this, and I will remove this, and I will show you one more thing that you can do.
Let me just restart the